Hi. Welcome to the Inside Java podcast, a podcast made by the people at Oracle who makes Java. My name is Delabassee, and I'm your host for today's episode 22. Today we'll discuss JEP 408, also known as the Simple Web Server, with Julia Boes. So Julia, this is your second time in the show, so welcome back. Can you introduce yourself?
Yeah, hey, thanks, David. It's great to be here again. Yeah, my name is Julia Boes. I'm a senior member of technical staff at Oracle's Java Platform Group. And last time around, I was here with Chris Haggerty, and we talked about record serialization. So that's an area that I would have worked on since until recently. And then apart from that, I also work on core libraries, all different kinds of areas, in particular networking. And then more recently, I joined Project Panama as well.
You are here today because you are also the owner of JEP 408 that introduced the Simple Web Server in JDK 18.
That's right. I worked on this part of last year. We completed JEP 408, I think, in January of this year, 2022. And I'm happy to tell you a bit more about that today.
Okay, cool. So first things first, what issue that JEP is trying to tackle?
Yeah, so there is many use cases where you might want some basic server functionality. A lot of those use cases are in the area of educational tasks or informal development or debugging. And we wanted to provide a tool that lets you hit the ground running with just one command really easily without any hurdles or ceremony to set up things to use that server functionality. There is 3 use cases that come into mind, although there's many different ones, but the ones that we thought of originally is web development testing. So let's say you want to have a local server client set up to simulate some responses and requests sending back and forth. It's also the case of web application or web services testing. That's where oftentimes URL maps to a function. So for example, app/browse maps to a browse function. And then while you're developing or implementing these functions, you might want to have some static files in place to have test the system and test the other implementations. And then the third use case, which we've probably all done before, is sharing files across the network. Let's say you have a remote server and you want to browse a directory. So that's where such a basic server can come in handy as well. So yeah, we wanted to help people with that. The wider goal is that we wanted to make the JDK in general a bit more accessible with this out-of-the-box tool that you can start really easily, that is very approachable. And it's just a nice little add-on to have in the JDK.
Okay. Now, the name Simple Web Server is pretty obvious. It's pretty clear. But I think it doesn't hurt to really explain what it is not for.
Exactly, yes. So Simple Web Server, or as we describe it, a minimal HTTP static file server. It's really just that. So it's a server that serves a single directory hierarchy, and it only serves static files. We were not looking for any kind of feature-rich server because a lot of really good alternatives already exist. So whether that's server frameworks or production servers. So we really wanted to do the opposite of that, a minimal server. We also don't provide any features like encryption, access control, or authentication. So really the minimal design of that server is to avoid any confusion with those alternatives.
Yeah, okay. The Simple Web Server will be added in JDK 18. Can you tell us more about it? So where is it located?
Yes, so it's available in JDK 18. The API points that we added and the command line tool as well, they are in the JDK HTTP server module. So as such, they are officially supported as a JDK API. In that module, we have a package called com/sun/net HTTP server. That package has been around since JDK 6, actually, and then was then put in the JDK HTTP server module in JDK 9. So it's been around for a long time and it's officially supported. And most of what we did now is use or reuse existing classes and methods. So we're not reinventing the wheel. We're using things that were already there to build or implement this basic server. And the central new class that we added in that module is called Simple File Server, and that's the class that provides three factories for the three server components that make this simple server work.
So you mentioned that the simple web server is extending the SUNNet HTTP API that was introduced in JDK 6, so a long time ago. So I think it might be good and useful to remind people what that API was about.
Yes, so the purpose for adding this API back then was to really just provide some high-level HTTP server API. It does support HTTP and HTTPS, and it allows you to write your own request handle logic and configure your server. The initial use case was to support JAXP, so the Java API for XML processing. And that works with application servers like Tomcat. But back then, we also wanted to support it outside of those external application servers. And that's why this package was added. So to add our own lightweight HTTP server in the JDK.
Yeah. And so the key takeaway here is that the new simple web server, it is leveraging that API. So we are not reinventing the wheel, as you mentioned.
Yeah.
So let's go into some detail now. You mentioned that the simple web server is made of two things, the command line tool and an API. Why do we have such distinction between the two?
Yeah, so I guess the most natural, or what we originally intended, was to have this command line tool. The name it has now that we ended up with is JWeb Server. So really just to have one command that starts the server in the foreground on the command line with minimal configuration. And that's really good for a lot of the use cases that we had in mind. I mentioned some of them. But then there are other cases. So let's say you want to use the simple server with some existing code, so programmatically either customize it further or add something that you've already written. Or let's say you want to take one of those components, the server or the handler, and adjust it or custom tailor it to your use case. So in that case, the command line tool kind of has its limits. And in that case, we wanted to kind of bridge the gap between this really simple command line tool and this more write it yourself approach of the old API. So we wanted to bridge that gap. And that's why we came up with a few API points to either retrieve the server components or to customize request handling further if needed. So yeah, as I already mentioned, the server implementation that is used by the command line and the API has three components. It's the server, the handler, and the filter, and I'll talk about that in a bit more. Yeah, and basically those three components can now be retrieved in the API, and then we also have a couple of API points to customize those components and to make combinations and composability a bit better.
Okay. But both the command line tool and the server instance that you retrieve programmatically via the API are using the same server implementation under the hood, correct?
Yes, that's right. And that also allows you to kind of have an easy transition from the command line to the API back and forth. So yeah, you know what you're dealing with in both cases.
So now let's talk about the server itself. So what are the specifications, the features of the server?
Yeah. Yeah, good question. So, as I said, it only serves a single directory hierarchy. You pass it that directory at the start. It only serves static files. And then, in terms of request methods, it only supports head and get requests, so the idempotent request types. Any other requests, let's say post or put, they receive either 501 response, not implemented, or 405, not allowed. In terms of HTTP versions, the server only supports HTTP 1.1. HTTP2 and also HTTPS are not supported. So now when you think about it, when a request comes in, I'm saying that the server serves a single directory, but how is a request mapped to that directory structures? There's basically three options. The first one is if the requested resource is a file, let's say some HTML file, then its content is served. If the requested resource is a directory with an index file, then the content of that index file is served. And in all other cases, so if we have files in that directory or subdirectories, then a HTML directory listing is returned to that request.
So you said that if the requested resource is a file, the content is served. So how does that work with the MIME type?
Yeah, so we're reusing an existing API, and we're using really basic MIME time support. So for example, if you have a HTML file, I think it's a plain text type, and if it's a .java file, then I think it's text as well. So yeah, really basic MIME type support.
The obvious one, I guess, are supported.
Yeah.
So yeah, so it's really a minimal static file server. Now, looking at the command line, how can one use it, and what are the options?
Yeah, so you start up your terminal and you type in JWeb server. You just have to make sure you're on Java 18 or later. And with that command, the server is started with default configuration. If startup is successful, there's a little message printed on the command line. You can see the local address where the server is running, and you can also see the absolute path of the directory that is served. So yeah, that's basically the easiest way to start the server. Apart from that, there's a few options for configuration. To see them, you can either use the man page, so that's man JWeb server, or you can use the --help or -h option to get a summary of the command line options and their usage. Basically, the four main bits that you can configure is the bind address, the directory, the output level, and the port. So for the bind address, the default is the loopback address. You can specify any other available address, including the wildcard. For the directory, it's the current working directory, so wherever you are in that when you run the command. Then for output, that's just some kind of logging. You can silence it completely. You can have some a default logging, or you can have a bit more of a verbose logging output on the command line. Then we have the port that you can specify. The default is 8000, but again, you can pass it any available port. And then we have two other flags. One is this help message flag, and the other one is version information. And then the last thing that you can do is stop the server, because once you started it, it runs until it's stopped. So you do want to use Control C to stop the server. Yeah, and just in terms of the logging output, as I mentioned, you can silence it, or when you run it on the default level, which is called info, then what you can see on the command line is for each request, you see the remote host, the date, the request line, and the status code. And if you choose the verbose level, then you can also see all the request and response headers, and you get an absolute path of the resource that is requested.
Mm.
And yeah, that's pretty much it. So it's minimal, but it's also configurable enough to serve most of the use cases. And yeah, if you do want to go further, then I guess you should use the API, and I can tell you a bit more about that if you want.
That's a good segue to talk about the API. So please, go ahead.
Yeah, so for the API, we already said that we're pretty much reusing the existing JDK HTTP server API. And I think to understand the new bits that we put in, it's good to look at the key abstractions that already exist in that module. So there is 5 abstractions. At the center, obviously, we have the server. The server is the entity that listens for TCP connections. Then we have a client that is sending requests and receives responses. A request and response pair is also called an exchange. Then the next one is the handler. The handler is the entity that is registered with a server. A server can have one or many handlers, and the handler is what holds the actual logic of the request handling. So where you might inspect request headers, you might compose your response and then send it on. And then lastly, we have filters. Filters are similar to handlers, but what you do with them is that you either put them before or after handler. So it's for pre or post processing of a request, and you can build whole chains and put them before the handler gets to see the request, or afterwards. Typical use cases would be either inspecting request state, or then for a post processing handler to do logging, for example.
Okay. When a request comes in, how does the server knows which handlers to dispatch the request to?
Yes, so for that we have yet another abstraction, and that's the last one, I promise. That's the context. The context is a mapping between the root URI path and a handler. So when a server receives a request, it checks what handlers do I have and which one has the context that matches the request URI path. So that's how the server dispatches a request to the kind of best matching handler. And then the handler is what does the callback to handle the request. And that's how that works. And the thing is now with the old API, so we're all just talking about the old API, you had to write all of that or most of that yourself. So you had to write the handler logic. And if you had a filter, also write the filter logic. You had to configure the server, and then you register the handler and the filter with the server. So there's a bit of a few steps involved here to get something working, even if it's only something simple as a static file server.
Mm-hmm.
So what we decided was we wanted to pull out the relevant components for this simple server, and that's the handler, the filter, and the server. And now what we did was we made those three components available via static methods so that you can programmatically retrieve them and customize them if that's what you need to do. And the class that we added to the JDK HTTP server module is called Simple File Server, has three static methods, and one for each of the components. So we have this method called create file server that returns a minimal but customized static file server. You can pass it a bind address and a port, the root directory, and an output level. So very similar to the command line. Then we have this method create files handler that returns your customized file handler that you can add to a server that you might already have or that you initialized. And then the last one is the create output filter. That's this filter that we also use on the command line for this logging functionality. So again, it returns you an instance of a filter, and then you can add it to an existing or a new server.
I think you mentioned some new API points for enhanced request handling. Can you tell us a little bit about those?
Yes. So one other thing we realized when working on the API was that it's really the handler that is at the core of what's happening here. It's doing the heavy lifting, so to speak.
Yep.
So we wanted, now that you can easily retrieve this this file handler with the new API, we wanted to also have ways to better compose and combine this handler with other things. So for this, we added a new class called HTTP handlers. And that's really just a class with two factories. One is handlers off. So that allows you to create canned response handlers. And the other one is called handler else, where you can combine two handlers on a condition. And I can give a bit of an example here. So let's say you have a request coming in, and if it's a GET request, you want to return the body of some JSON file. In any other case, so if it's, let's say, a POST request or anything else, you just want to send a 4 or 5 not allowed response. So what you can do now with these two new methods is you create a canned response JSON handler that always returns a 200 response with the body of some JSON file. And then you have a second handler, you might call it not allowed handler, that always returns 4 or 5 and an empty body. And then you have this other method, handler else, and now you can combine them on a predicate, so on a condition. So if the request method is get, you dispatch the request to the JSON handler, and otherwise you dispatch it to the not allowed handler. So with those two methods, it's really easy now to kind of combine and create handlers and write your own custom tailored logic, either with using the simple file server handler or with any other handlers that you might use for your own testing needs. Yeah, and then there is one last method. It's called filter with request. Because what can happen, especially in debugging or kind of edge case testing scenarios, is that you might want to slightly alter the request state. A good example here would be that you want to add a header to all incoming requests because maybe your API needs it, or you want to simulate some custom header that is required by an application. So in that case, you can use filter with request. That returns your pre-processing filter, and you can either only inspect the request state, or you can also adapt it. So you can change the URI, the request method, or as I said, the headers. And again, that's kind of a neat way to custom tailor something that already exists for certain edge cases. And so with these 3 new API points, we really doubled down on handlers and how you can more easily work with them and combine them.
So what does the filter has access to?
Oh yeah, I forgot to mention that. So the filter only has access to immutable request state, and that is the request URI, the method, and the headers. So those 3 entities or states you can inspect and possibly change if you want to.
Mm-hmm. Okay. So now the simple web server. Given the scope of this effort, I think it's fair to say now that we have the command line tool and the API that developers shouldn't really anticipate any drastic change going forward. Is that fair?
Yeah, I think I would agree there. I mean, the JEP 408 is a small-sized enhancement. I don't think we'll see a lot of follow-up work. Maybe there will be a small bug or a small fix here and there. We want to keep the server and the command line as it is, and that's simple. Given that it's put a lot of work into it, we have received a good bit of feedback during the development process, and as I said earlier, I think if you do want to use this in more elaborate or advanced cases, you should really turn to alternatives.
Something we should mention, that is part of the GDK. So that's also one of the reasons why we don't want to bake into the GDK of full-fledged server frameworks.
Yeah.
Now, you gave us a very good overview of the simple web server. Is there anything you would like to add on the topic?
Just because we are already running out of time, I'm looking at the clock here. I just want to briefly mention it. I did write an article back in December of last year where I cover a few kind of less obvious but very interesting use cases of the simple web server API. So the first one is there are cases where you might not want to tamper with the actual file system to create your static files. Instead, you can use an in-memory server, and there is Google's Java in-memory file system that you can easily use with our API because it supports the Java NIO files API. So in that case, you don't have to actually create file system resources, but it's all in memory. And then once you stop your program, you don't have to delete or clean up anything. It's all just a runtime solution. The other thing is you can serve the contents of a zip file. That might be an interesting case as well. And you can also serve the Java runtime directory to check which classes are available at runtime. So let's say you want to diagnose a server and see what classes have been loaded. So these are just a few, interesting cases. If you do want to check it out, check out the article.
Yeah, I will make sure to include the links into the show notes. And I have to say that the last one is a pretty smart example. So what would be the call to action?
Just go and try it out. We are always happy about feedback. We always like to hear from people using APIs, command line tools. If you do have any feedback, make sure to send it to the NetDev mailing list. That's where anything networking is discussed in the OpenJDK.
Okay, cool. As you say, we are running out of time, but you mentioned in the intro that you are now working on Panama. So can you say a word about it very quickly?
Yes, so I joined the team around Maurizio Cimmadamore a while ago, helping on Project Panama. Panama looks at interconnecting the Java virtual machine and native code. Currently, we are in a transition from incubation mode to preview mode. So one of the more recent things I've done is to move away from the incubator module to Java base. And as I said, we are aiming for preview status soon. And kind of doing other work to mature the API, the documentation, further evolving it. It's an interesting project. We do have our own repo. It's called Panama 4ains. If you want to check it out, there's also the Panama Dev mailing list.
Very exciting time, I have to say. Okay, Julia, thanks a lot for your time. It's always a pleasure to have you, and I'm pretty sure you will come a third time for another episode. So thanks, Julia.
Yeah, thanks, David. All the best.
Bye.